Assalamu alaikum. Thank you very much for inviting me on the third International Brain and Biomedic Medicine Conference organized by Department of Physiology and Pharmaceutics at Government College University, Festival. I am Dr. Shugufta Saeed from University of Veterinary and Animal Sciences of War. And the topic of my presentation is green synthesis of zinc oxide nanoparticles using Acanthus aspera leaf extract and evaluation of its antibacterial potential. First of all, introduction. Poultry industry gain a very important role in economic development of Pakistan, and poultry meat consumption is progressively increasing worldwide, reached 14.2 kilogram per capita per year, and mortality rate in poultry has been growing everywhere due to outbreak of several diseases. The major drawback in advancement of poultry industry, which lessen the prime production of pork and most of the microbial pathogens are Salmonella and Campylobacter, and microbial safety of poultry meat product is an important issue in context of increasing consumption and production. So, these are the Salmonella gallinarum and Salmonella enteritidis properties. Salmonella gallinarum is a dwarf-shaped gram-negative bacterium and it contaminates egg, thus making it potent infectious agent for humans. While the Salmonella enteritidis is a rose-shaped gram-negative facultative anaerobe and it transmitted via improper cooked meat, contaminated food, and water. Antibiotics, antimicrobial agents have long been used to treat different poultry diseases and also reduce mortality associated with severe cases. However, bacteria are becoming resistant against these antimicrobial agents. So, Salmonella carinarium present in chicken were resistant to doxycycline, polymyxin, streptomycin, and gentamicin. And Salmonella enteritidis resistant to ampicillin, chloroamphetamine, and lamicin. Nanoparticles are used as an alternative source, and the unregulated use of antibiotics provide the impulse for bacteria to become drug resistant, and nanotechnology is becoming as an alternative source against antibiotic resistant pathogens. And nanoparticles have developed antimicrobial approach to fight for treating severe bacterial infection and the basic size is less than 100 nanometers. So the green synthesis of nanoparticles is gaining importance day by day, and it has following properties like it is an expensive technique and it's time consuming. Uh, and it has advantages over conventional method because conventional methods are expensive, time consuming, and use of chemical compounds like organic solvent as reducing agent. So various metal oxide nanoparticles like iron oxide, titanium oxide, copper oxide has been synthesized using plant source. So zinc oxide nanoparticles have been key area of interest due to their distinguished antimicrobial properties. And zinc oxide is an inorganic component, appears as white powder insoluble in water, and the activity of zinc oxide against various pathogens like Staphylococcus aureus, Salmonella, Bacillus subtilis, and E. coli has been reported. Acanthus aspera is a species of plant in Amaranthecia family, and its common name is carp or devil worship. Distributed throughout the world, and it habitated dry and warm places, and it has 1 to 2 meter in height and commonly found as a plant. So, statement of problem of this research is the extensive use of antibiotic has raised concern about increased resistance of Salmonella species in poultry and cause serious health hazards and economic losses. Hypothesis zinc oxide nanoparticles produced by leaf extract of Acanthus aspera have antimicrobial potential against poultry pathogens. So objective, there are two objectives of this study. First one is synthesis and characterization of zinc oxide nanoparticles, and then evaluation of antimicrobial activity against volatile pathogens. Material and methods. First of all, collection of sample plant, and it was procured from the Qaid-e-Azam campus, Lahore, from the Punjab University, and after collection, it was washed with distilled water and then dried in 160 degrees centigrade for 1 hour and grinded to make the powder. Then extract preparation. Extract are prepared with distilled water and then heat it for 25 to 30 minutes on heating mental, and then filter the extract through the filter paper, and then obtain filtrate are stored. Then preparation of zinc oxide nanoparticles, 10 ml of leaf extract of Acanthus aspera, and it was mixed with 0.1 millimolar zinc acetate and sodium hydroxide, and then it was placed on magnetic stirrer for 4 hours, and after the 4 hours centrifugation was done and the pellet was washed with distilled water and absolute ethanol, and then the obtained mixture is placed in hot air on to get the formation of zinc oxide nanoparticles. Then characterization of zinc oxide nanoparticles were done using following techniques like UV visible spectrophotometer, X-ray diffraction, SEM analysis, FTIR, and atomic force microscopy. Then evaluation of antibacterial activity of zinc oxide was done against Salmonella gallinarum and Salmonella enteritis. Method used for evaluation of antimicrobial activity was Dix diffusion method and minimal inhibitory concentration. Well diffusion method was done to check the antimicrobial activity of Acanthus asparagus, right? uh, Synthesizing oxide nanoparticles. Wells of 6 millimeter were made with fork borer or nutrient agar plate, and then plate surface was inoculated by swabbing microbial inoculum, and then 50 microliter of zinc oxide nanoparticles was poured, and then tetracycline and DMSO was used as positive and negative control respectively. Then it was incubated at 37 degrees centigrade for 48 hours. And then diameter of zinc zone of inhibition was measured. Then minimum inhibitory concentration of zinc oxide nanoparticles was obtained by using different concentration like 180, 60, 40, and 20 microgram per ml. And then antibiotic tetracycline was used as positive control, and DMSO was used as a negative control, and then culture was incubated at 37 degrees centigrade for 24 hours, and MIC was calculated. Then statistical analysis was done using by mean and standard deviation on SPSS. These are the result of UV visible spectroscopy, as we can see that at 370 nanometer zinc oxide nanoparticle show a peak. Then these are the result of X-ray diffraction analysis that was performed of synthesizing oxide nanoparticles. These are the atomic force microscopy image of the zinc oxide nanoparticles that basically show the surface morphology of the zinc oxide nanoparticles and topography cutting. And these are the FTIR analysis that basically represent the presence of different functional groups present in the zinc oxide nanoparticles. And these are the SEM image scanning electron micrograph that basically represent the shape and size of the zinc oxide nanoparticles. These are the antimicrobial activity graph that basically synthesize that basically represent the against the Salmonella enteritis and Salmonella gallinarum, as it represents minimum heavy concentration was reported against 0.19 milligram. against the Salmonella enteritidis, and greater than 0.39 milligram was reported against the Salmonella billinatum. These are the images of well-defined method that represent the zone of inhibition. These are the MIC of nanoparticles for Salmonella billinatum and enteritidis that was 0.39 milligram and 0.195 milligram respectively. And then conclusion, zinc oxide nanoparticle synthesized from Acanthus astralis extract has been proved as a better antibacterial agent against poultry pathogens. These are the reference, and thank you very much.